Today we'll be doing right view of binary tree, and it is super important because after this we will be doing more questions of graph where we will be using exactly same concept, the level order traversal of breadth first search, and it is so commonly asked in interviews. It is super important. So I'm making sure that you have understood yesterday's concept very well. If you have any doubts from yesterday's concept, let me know. If not, because we are anyway going to do the variation today, so it should be more and more clear. So that is the purpose of picking up this question today. And I hope the voice is better, and I hope you're able to see the code and the question as well. Okay, so the question is the right view of the binary tree. Something is not right the way it is coming. Okay, so what am I going to do? I'm just going to switch from this to the original voice. Is this fine, guys? Is this fine? I've just moved away my mic. Is this fine now? Yep. Thank you so much for letting me know. Okay, great. So I'm using the normal mic itself that I use always. Okay, fine. So this is the question that we are doing today. Given a binary tree, find the right view of it. So what does right view of a binary tree mean? If you saw the thumbnail, I had put an eye over here beside the tree, right? Why had I done that? Right view of the binary tree is set of nodes visible when the tree is viewed from the right side. So here, see, if you see from the right side, you can see 1, which is the topmost. After that it is 3. You cannot see 2 because see, here is the eye. You can just see 3. You cannot see 2, right? So that is why, okay, I am guessing it is mirrored. So you have to understand like this. So there is 3, you will not be able to see 2. Similarly, over here there is 4. Behind 4 there is 5, 6, 7. So you cannot see 5, 6, 7. You can see 4, right? Similarly, you can see 8. So for each level you can see one node. Which is the node that you can see? It is the rightmost node. Okay, so first of all you have to identify that why this is a level order traversal, or why you are going breadth first search over here, because it is right view and on each level you can see only one node. So basically what is your what do we have to do? We have to find the rightmost node in each level. Is this clear? So you should also be able to identify that why does this question is like, why is this question a level order traversal or a BFS question? Okay, so here let's take more examples. Here on the first level you can only see 1. Here there is 3 and 2. So obviously 3 is behind 2. So you can see only 2. Over here you can see 10 on the first level. In the second level there is 20 and 30. So you can see 30. You cannot see 20. On this level there is 40 and 60. You can only see 60. You cannot see 40. Okay. So it is like that. So we have to be writing what? We have to finish this particular function. I am just collapsing this. We have to finish this function. We have the root and we have to return vector of integers. Basically every level one node we have to find, right? So till now, if there's any doubt, if there's any problem at all, let me know. I'll get started with the code, and then we will see where all do we have any problems, where all we can see that okay, why are we doing this. First they have to return vector of integers, so I'm just initializing the resultant. Then I am making a queue. Why am I making a queue? Because we have to do level order traversal. In the level order traversal, we have seen that we need first and first out. The nodes that were visited first, we need to visit the children of their nodes first. So if we have visited 2 first, we need to visit the children of 4 and 5 first. If we have visited 3 first, we have to visit the children of 3 first. Okay, so it is like that. That is why a queue, because it is first and first out. Why am I storing a queue of nodes and not queue of integers? Because I need to refer to the children. So if I have only integers, I will not be able to refer to the children, right? So that is why I am doing queue of nodes. Okay. Any doubt till here, guys? I am checking the comments also. So if you have any questions, you can let me know. Okay. So we have initialized the queue. Now what am I going to do? I am going to push the first element that I have. See if this, okay, now another question can be, yesterday we had not put a check that, you know, if not root, then return null or return res from here itself. Why do we not have to push that? Why do we not have to check that? See, even if it is null, when I'm pushing it, see, I am putting a check over here that while queue is not empty, and I guess over here it is given that minimum one element is going to be there, number of nodes is 1. Otherwise what would happen is that I would lead to crash. So we have to think of these things that okay, what happens that, you know, when it is null. Again, we have done so many tree questions. That should be the first case that you should be thinking. If root is null, what is going to happen? Here we have seen that at least one number of node is there. That is why I have not put a check. Okay. Now what did I do? I pushed the root. So there is one element in the queue for sure. And then I'm going to keep going through this while loop until the queue is empty. Now I'm going to make sure I visit all the elements and queue becomes empty only after that. Now, how is this different from yesterday, the level order traversal? Here we have to make sure that we know at each level what are the nodes. See, at the first while loop, we have only 1. Okay. After that, we will have the children of 1, which is 2, 3. Then next time we get into the while loop, we have to make sure that there is 4, 5, 6, 7. So what am I going to do is that at a time, I am going through one level only. So what am I going to do over here? Don't worry if it is not clear, it will be clear. I am taking out the size of the queue. So initially the size of the queue is going to be 1, then it is going to be 2, then it is going to be 4. I am assuming that there are all the elements. After that they will be 1. If there were no elements, okay, obviously it will be less. See, if there was no 7 also, then also the size is 3. So I know that where do I have to stop. So what am I going to do is I'm going to add a for loop over here, and I'm going to visit all the elements at that particular level. So I know that I am going to the elements at this level. Why am I doing this S wala part will be more clearer when I go through the rest of the code. And you have to think about this, that okay, why are we needing a size integer over here? We did not need this yesterday when we were doing level order traversal. This question is different. How? Because we need this size over here. Okay, why do we need it? We are going to see. So at each element, what are we doing? We are pushing the left and the right children. So at every element, I'm actually changing the number of elements in the queue, right? Because I'm pushing new elements. So when I'm at 2, I've already pushed 4 and 5. So when I come to 3, I've pushed 4 and 5. So that means I've already reached the next level. So what am I going to do is, in this while loop, I'm going to visit only 2 and 3. And in the next while loop, when I've already pushed, I'm going to visit 4, 5, 6, 7. If it is not clear, think about it again. What do I have to do? I have to make sure that in every iteration, I'm going through only one level. When I'm at 2, I have already pushed 4 and 5. But I have to make sure that I get out of the while loop after 3, because I have to go to the next level also, right? So just for fun has replied, for loop needed for storing the rightmost element. Exactly, it is for the rightmost element. Shiva has also replied, because we have to take last element of every level, so we need to track levels as well. Very good, guys. So we are understanding that why are we doing this. Always we don't need to keep track of the size. Yesterday we didn't need that. Today we need that. Why? Because we need to keep the track of the size of the level at each level, because we need the rightmost element. Okay, so you are able to understand. See, I understand that few people are replying and others are not. So for those who are not replying, don't be shy. Feel free to ask questions. It's fine. Like, no one's over here to judge. Everyone is learning only. Okay. So what am I going to do? I need to take an element out. So I am going to call it F. I am making a new node over here, but there is a problem over here that I need you to think of it yourself and tell me what mistake am I making over here. Okay. So I've taken out the frontmost element. Now what am I going to do? I've referred it, I have it stored, so I'm going to pop it up. Now what am I going to do? I am going to take its children and I'm going to push it if they exist. Okay. So if there is a left child, what am I going to do? I'm going to push the left child. Similarly, if there is a right child, so if F has right, what am I going to do? I'm going to push the right child. Okay, so I have pushed the new elements, but now what do I need to do? I need to push the rightmost element in res.pushback. So what do I do? After this for loop, the last element that I would have been there at s minus 1, right? In this, basically in the queue, at the index s minus 1, I need to refer to that element to push it back. You get the problem that I am stuck at, because I need I value at s minus 1, but I have come out of the for loop. Now how do I get that? So one way of doing that is this node value that I have, I'm going to initialize it outside. So this F value I will still have. So what am I going to do is I am going to push F ka data. How many of you have not understood this? I want you to tell me. So here what am I doing is, see, the rightmost element is going to be at s minus 1 index, right? So when I am out of this for loop, the value of this F has the element that I want. Right, it has the rightmost element. I need to refer to that. So what did I do? I just made my node outside. So I have the F data and I've just pushed it. Why am I not pushing inside the for loop? Because I am just traversing through the level right now. Once I'm at the end of the level, once I have done the for loop, I need to push my values into the res. Right? Can you understand this much? If not, let me know in the comments. Okay, I'm here to clear your doubts. So what have we done till now? First we created a queue. Why? Because we need first in, first out. Then what did we do? Then we knew that okay, now we have to deal with the level size. We need to know how many elements are there at each level. So what did I do? I created a for loop, and for each loop, like that is, I know that how many elements are there in this. So suppose there was only 2 and there was no 3, then what would have happened? Then the size would again be 1. Now here when I go through this size, when I get out, again I have this 2, right? So it is not necessary that there are 2 and 4 and 8 elements in the tree. There can be any number of elements. Like over here there is only 8, there is only one element, right? So how am I dealing with that? I am dealing with that because I have this size over here, and at each time I am pushing it only if there is left cut data. Now there will again be questions, there will be variations of level order traversal where you will need to push the null pointers as well. Note that we are not doing it over here. We are not pushing the children if they are null. So there will be variations of the question and we will be covering them in the future. But you need to understand that when do we need to push null, when do we not need to push null. Here we are referring to the parents and we need the children only when they are not null. So here I have pushed the rightmost element. Now what do I need to do? I just need to return the arrays. Any doubts still here, guys? I am reading the comments while this is compiling. Okay, there is some issue. Samir is saying we can also push right node first to the queue and store the result at I is equal to 0. Correct, you are right. So instead of going left to right, what Samir is saying is actually very smart. That instead of pushing left, what am I going to do is I am going to push right first. So right now what we are doing is we are going like this. We are going from left to right, right? So instead of doing that, in some questions you can be asked to go in zigzag manner or from right to left. So for that you need to understand that sometimes we can be pushing the right element first. So Samir is suggesting that what you do is you push the rightmost element first. So in all the times what will happen is the first element that you will have in every while iteration, that will be your answer that you need for that level. Are you able to understand this, guys? Very good, Samir, for giving us this alternative solution. And I hope others are also able to understand. If you have any doubt, let me know. So what he is suggesting that instead of pushing the left child first, we will be pushing the right child first. So in that case, in every while iteration, we will have at the 0th index itself, we will have the rightmost element. Right now, our index is where it is at s minus 1. But we will still be going through the for loop. We will still need the node pointer outside. That will still be the same. But instead of at the index s minus 1, it will be at index 0. Have you understood, guys? Let me just quickly try and compile this again. Okay, there is some issue. Let me just quickly check this out. Okay, I guess it's not login. Give me 1 second. I guess I got logged out. Yep. Okay, so the code is already there. Okay, so this compiles. Let's submit and see. All the test cases have passed.